Hello and welcome to our session about process selection and facility layout. That's chapter 6 in your operations management, and this is part of the QDC1 course. So what is process selection? Process selection refers to the decision on how you are going to produce goods and services in terms of how they're going to be organized, and how you're going to lay out your facility, and what kind of process you're going to use to manufacture whatever you're going to sell. Again, it could be a service and it could be a product. And really, when you think about it, if you had a great idea, you were starting your business, be it a manufacturing business or a service business, you go and you decide, okay, I'm going to go and buy the machines that I need for my factory. You have to decide what kind of working process you're going to have. I mean, is it going to be like a little shop, like a wood shop where you're going to manufacture this high-end furniture by hand, or is it going to be the IKEA type of furniture, which is going to be kind of like an assembly line? Is it going to be in batches? Is it going to be something that you're going to build some big a product that you sell one a year? One of those fancy cars that cost you like $2 million to buy the car, and they manufacture 5 of those a year. So really, you have to decide and to think about what is going to be the process and the layouts of how you're going to actually manufacture and create this product or service. So technology is obviously one of the most important elements in terms of your process, especially today, but it was always relevant. Technology was not, when we say technology today, we're thinking, computers and stuff, but technology even back in the Middle Ages was very important in terms of manufacturing. So technology really covers what do I need, and how and how much I'm going to pay to get my stuff produced. And there's always, a cost-benefit decision you have to make here. Yes, there might be a machine that does everything for you perfect. You don't have to hire anybody. It's a red button, you push it, jam, it produces it for you, but it costs $100 million. Now you think, okay, 100 million, but I'm only going to be able to sell in the first few years 20 million worth. It makes no sense for you to buy this machine right now. But let's say you're predicting, or you actually have sales of 500 million, then buying a machine that costs $100 million makes sense. But again, there's always a trade-off. Nothing is free. So in terms of the technology that you're going to acquire, you also have to remember that it's not just about money. It's not just about, okay, how much is going to cost me. There's also integration. How are you going to integrate this into an existing facility? If we're talking about training, if we're talking about a facility space, a factory has a limited amount of space. And also the human consideration, employees, do you need to hire more people? The people you hire, like I said, it's not just training, but is it really going to upset them? It's going to upset the way they work. People are not big fans of change. So really, when you go and decide, okay, I'm going to get the coolest, latest technology, it's not just that. You have to really look at the big picture of everything that you need to take into consideration when you choose the technology that you are going to use in order to manufacture and produce that, whatever service or product you're going to produce. Now, process selection has to answer 3 questions: variety, the flexibility of the equipment, and the volume. And we have let me go back because it's really hard to see here, and I hope you can see it with the video. This slide here is kind of a white triangle, not very good choice of colors. I took this slide from the book website. But what you see here is that you have the 4 basic types of process selections. You have the job shop. In the middle, you have the batch. Here on the lower left, you have repetitive and continuous. And what each one of them means, and that's how they each one answer these 3 questions of variety, equipment flexibility, and volume, is a job shop is just kind of like the example I gave, like a woodworking shop, a mechanics shop, where you have different machines and you have, you know, employees moving between. The employees are very, very skilled, but it's very low volume, very specialized type of manufacturing. So a job shop would work for, you know, if you are a moms and pop shop that is targeting a very niche market or a very unique type of low volume manufacturing. Then you have the batch, which is kind of like a job shop, but it's, you know, it's kind of still small. It works in batches, not huge amounts. You know, you're not thinking here about automobile factories. You're thinking about a bakery. You know, a bakery is a perfect example of a batch. Think about, you know, they're not going to create one cake at a time. They create tons of muffins and they have a process, but it's not like a factory in the way you kind of think about it when you watch a movie. Then you have the repetitive. Repetitive is when you create X amount of products, but they're very similar. You work on very big volumes. It doesn't make sense for you to have it if it's not. And it's what, you know, it's the assembly line. It's like the pencils, the automobiles that are generated in a automated, semi-automated assembly line where the workers don't have to be very skilled, large volumes, and there isn't much flexibility, right? You're not gonna, you know, if you have a machine that's designed to create pencils, it's kind of gonna be kind of difficult to change it to create, I don't know, iPhones. I keep on coming back to iPhones. I don't even own an iPhone, but the point is really that repetitive is makes sense when you have big volumes and you don't need a lot of flexibility. And then you have the continuous, which is when you are working your factory 24/7. Think about electrical company, right? You know, water company, even cloud computing, right? That's more, you know, new age, where you have to continuously provide service 24/7, 365 days. Your factory is working, and obviously, when you're talking about something like this, you're going to have very little flexibility because it's usually big plants. If it's a power plant, power plants are huge. You're not going to have a lot of variety in terms of what you're manufacturing. You're manufacturing electricity. You're manufacturing cloud space, etc. And the volumes are obviously going to be very big to justify this type of investment. As part of every factory, and this is, even in service-oriented, like a supermarket, you might even have some type of automations there. But definitely in a factory, you're going to have automation, and automation is, it's exactly what you think it is: machines doing the work. And you have 3 levels of automation. Fixed automation is, it's the lowest level. It's a machine that can just basically do a few things. Doesn't have usually the ability to be programmed in terms of changing what it does. Think about a welding robot, not a robot, a welding machine that goes, welds a point and does that gazillion times an hour. The next level is a programmable automation, is where you have flexibility in terms of programming what the machine does. So it's a little bit more, it's a little bit better than the fixed automation, where you can have a little bit more variety in what you're going to do with the machine. And the third level is flexible automation, which is, the highest level, where you still, this is not completely flexible, but still you have the ability to change the machines and have one machine do a lot of different things. When you go and decide, okay, I'm going to automate, obviously if you have a factory, you're going to have some little automations, then you want to make sure that you're not spending too much money. You always go back to that as a business person, right? How much money am I going to spend? What kind of risks and benefits am I going to get from automation? But you also have to think that automation, there's quality, there's customer satisfaction, there's labor relations, right? If you have 500 employees and you say, oh yeah, I'm going to just fire everyone and bring machines. Now, that could be theoretically a great business decision, but not really something that you can implement if you have labor laws, or if you have unions, and sometimes it just doesn't. Machines are not always the best thing to go about. So basically, this slide is saying that deciding to go with automation is not just, okay, let's go with the thing that can automate the most. Sometimes, and in most cases, you want to find a perfect level, equilibrium. That's the magic word in business, equilibrium of the best solution in terms of automation. You have several automation technologies. This slide in the book only talks about 3, but there are a lot more than 3 today. You have the computer-aided manufacturing, the CAM, which uses computers in the process to control, and that's most factories today are going to be CAM. And then you have numerical control, the NC machines, which are a little bit, they're older machines where you they're not necessarily connected to a centralized computer. They have a computer on them, maybe not even a computer. Sometimes they can be fully mechanical, and they can, use pinch cards. I mean, this is really old technology. I can't imagine factories that still have NC machines, but still, the idea is that you have machines that are not computerized in terms of how they're controlled. So they might have some computer on them, but you not necessarily can control them remotely in one big centralized computerized room. And then you have the robots, which everybody knows what a robot is. Facility layouts. So layouts, obviously, is how are we going to set up our machines, and this is super important. And think about layout not just in terms of factories, even though the book and in general this course will focuses more about manufacturing, which for us as Americans is something that not a lot of us have ever been to a factory or can really imagine a factory, but even if you think about service-oriented, the layout of how people sit and next to each other, even in your own work, if cubicles and if the manager is in an office that views everybody, the layout of how you put your production units, your process is extremely important. There's no doubt about it. You want to make sure that it totally makes sense. There are basic types of layouts. You have the product layout, the process layout, the fixed position layout, and the combination layout. Now, the product layouts, that is more really the factory. You're thinking about, I need to create a product. It's more like assembly line, continuous type of processing that we spoke about before. I have a product that I need to generate, to produce, and I want to make sure that the layout is optimized. So for example, if I'm manufacturing a car, then I want to make sure that I get the body, and then I get the engine, and then I put the wheels on, and everything makes sense. So there's a smooth flow of how the products comes from raw material all the way down to what is actually being sold to the customer, right? So that's a product layout. Process layout, which is more, like the name implies, is more about the process. This is something that you'll see more in a job shop, or even in a batch mode, like in a bakery, where you want to make sure that the layout matches the process of manufacturing whatever you need to manufacture. So if I'm creating chairs and tables, that I have my cutting station, and then after I cut it, I can go to my sanding station, and I can then move around and get to where I do my drilling. So it's more of process-oriented type of a layout. The fixed position layout, that's for big boats, when you're building a boat, or if you're building an airplane, if you've ever seen that on TV. You can't do it on an assembly line. It's definitely not going to work with a batch or a process layout. So you're going to need to have the plane in the middle, and everything comes to the plane where you just put it on and you build it in those huge hangars. Combination layouts are, that's just like the name implies. They're a combination of the product and the process. So think about a supermarket. That's a good example. Supermarket, you can have the process layout, which is somebody, comes and they comes with their groceries, and then, they check out, and after they check out, we put it in a bag, and then, it's all the different processes. But then in the back, in the warehouse, everything is automated with an assembly line where everything is on conveyor belts, and it's really, for more product oriented, a lot less flexible. FMS and CIM. FMS, flexible manufacturing system, is when you have a bunch of machines that are they're meant to handle intermediate processing, which is more for a job shop or a batch process, and you can use them to do a lot of different products. And again, I like to give this example because I love working with wood, like a wood shop. So you have a lot of flexible, I have my work table, and I have my drilling and my cutting area and my sanding, and I can use all my different tools to do different things, and it's not like I'm limited with my tools to do one thing, and I have a lot of flexibility to move them around and to produce a lot of different products. But they're also similar. I can't do metalworking. I don't have that equipment. So, and also in terms of the type of wood stuff that I can do, I'm limited. The computer integrated manufacturing, that's what you will see in the big manufacturing. That's where, and that's usually, most factories today in the world, when you think about, automated factories, they're going to be computer integrated manufacturing. Everything is computerized. Everything is connected to one big brother that controls the manufacturing process. So designing a product layout, line balancing, and the term line balancing is going to show up during the book and a couple of other subject because chapters, because it's very important. Line balancing basically says that you have to make sure that the product layouts, if it's machines or if it's the workers, are sequenced in a way that they need to perform. And what does that mean? It means that if again, let's take the automobile example. It makes no sense for me to first paint the body of the car, and then I start doing the welding, right? I want the paint to be over the welding. Basically, you want the sequence. You want the layout to follow the sequence of how the product. Of how the product is being manufactured. Now, another concept of line balancing, and that's the balancing part of it. You want to make sure that overall each process takes about the same time. You don't want to have bottlenecks. You don't want to have parts of your manufacturing process being inefficient and holding everyone else. But also there's the fairness, and you might say, hey, we're talking about factories, we're talking about business. What does this have to do with fairness? It has to do because if you're working in a process, and again, don't just limit yourself to thinking about a factory. If you're working in a service-oriented place, it really bugs you when you have to do 90% of the work, and then everyone else is just doing the rest of 10%. You want it to be balanced. It doesn't make sense for having one station doing the majority of the work and then everyone else just waiting there. You want it to be, as the name implied, balance. So when you design a process layout, really the main issue in the layout is where relatively you're going to place each department, and then you have to measure the effectiveness. So as you want to make sure that you are minimizing your costs, and cost is not just the money, it's the distance, the time it takes for you to produce whatever you need to produce. Now let me give you an example. Let's say you need to decide where to put the materials the wood materials for your, let's go back to wood, the wood materials for your table factory. Are you going to put them 2 miles away from the cutting area, which is the first area that they go into, or do you want them to be as close as possible to the cutting area? Right? You want them to be as close as possible to the cutting area because you want to minimize the distance and the time it takes for you to move the raw material to the first station, etc., etc. And really, this is complete. This just follows common sense, which surprisingly is not as common as you would think it is. Everybody worked in a place where the process layout made no sense, where you'd be like, hey, why do I have to go 3 stores up, 2 stores down, and then 5 stores up again? Why isn't everything laid out to follow the process? So every time that happens to you, you should know that the person who designed the layout didn't take into consideration the actual process. So that's it for this presentation. The book has a little bit more information in terms of the layout, the different strategies in terms of designing the process layouts, etc., etc. But generally speaking, I highly recommend to go to the book website and doing the quiz. But generally speaking, the process layouts and the process design follows common sense. It really is what you would do if you were designing or hopefully you would be doing if you were designing your own factory or your own business. Anyway, I hope this helps you, and have a great day.